Right, let's welcome back. Let's continue with this example 7.13. I've already put it in my OneNote so that I can scratch a little bit here. Okay, this thing, the input is a sine wave, about 20 volts, and then we have a DC voltage of 5 volts that way, and then V diode, and then V out. Okay, so when on the positive cycle, current will flow that way. On the negative cycle, current will flow that way. But when V in is a negative something, you must minus with this V of voltage of the battery. Okay, let's do some analysis here. Let's do some KVL here. We have a V in plus 5. Okay, why plus 5? Because it's a voltage source, plus 5. And then diode is a voltage drop, so it becomes minus VD. And then here is a voltage drop, so minus V out equals to 0. Okay, so V out, we rearrange this equation. V out equals to V in plus 5 minus VD. VD is 0.7, so V in plus 4.3. Okay, so you need to draw the graph. Okay, this is the input, and then what is the output going to be? Right, so let's plot the graph for the output. Okay, this is for the input line, 0 volt line, and then negative, and then 0 volt line. Let me redraw it. This one here, slightly off. Okay, so if V in, this is V out here, against time. If V in equals to 0, which means here at the 0 point. Okay, V in equals to 0. What is V out? So we use that equation. V out equals to V in plus 4.3 volts, which is equals to this is V in here. So when V in is equals to 0, V out, so replace that equals to 0, so it becomes 4.3 volts. So here V out is at 4.3 volts. So when V in is 0, V out is 4.3 volts. Okay, when V in is equals to what is this, 20, so what is the V out? (20 plus 4.3 equals to 24.3 volts). So let's say here is 24.3, so that's your V in, your V out. Okay, here is where the 0 volt, V in is 0, V out here is the same as 4.3 volt. Okay, what if V out is, when is V out going to be 0? So let's put it in the equation. If V out equals to 0, so equation is V out equals V in plus 4.3 volts. So when V out is equals to 0, so V in equals to minus 4.3 volts. So when V out is equal to 0, which is about here and probably here, so V in is minus 4.3. If I draw it correctly, so it was here. Okay, so when V out is equal to 0, 4.3. Okay, when V out is is minus 20, or when V out, let me rewrite this. If V in equals to minus 4.3, V out should be 0. Okay, when V in equals to 5, V out equals to, what do you think? V out is 0. Why? Okay, it's because any negative numbers no more than that, the diode will be off. Anything negative than 4.3, diode will be off. So the output will look like here. Oops. Here. The cycle will repeat. Okay, this thing will repeat like forever until it is turned off. So now you have the output graph from the input graph here and with this circuit. So I hope you understand how to calculate this. Right, next is I also copied here example. Okay, if you look at the answer in the slides, you will see slightly different answer, because this is with the assumption of an ideal diode. Okay, what we are not going to use ideal diode. We are going to use actual diode. Okay, we are going to use actual diode because in your lab you will use actual diode. So all the calculations here will not be used. Okay, you follow my example calculation. Okay, in your exam later on, or in your test, or in your lab, you will have to follow the actual diode. Okay, if it's mentioned as a silicon, then you use 0.7. But most of the time I will be using as a silicon. Alright, let's look at another example, example 7.14. Okay, and let's look into this. Okay, this is example 7.14. Right. Okay, now the input is a slightly weird input voltage, whereby the positive part is a 20 volt DC and negative part is the 10 volt DC. It's a square wave, but positive and negative is different. And the circuit is the same as before. If you can see here, it's 5 volt DC supply there, diode, V in and V out. So the equation is the same. V out equals to V in plus 4.3 volt. Is that correct? Okay, so it's the same equation. Same equation, same circuit. Now, what if V in equals to 20? So V out equals to 24.3. So the graph will follow the input. Okay, V out equals 24. The pattern is following the same. 24.3 volts. Okay, when V in equals to minus 10, V out equals to V in plus 4.3. So what's the value? Minus 10 plus 4.3. So what do you think? What's the answer? So that's the trick here. If you see again, the diode when you have negative voltage, it is off. So this does not apply anymore. V out is always 0 when the voltage is negative. Because why? This is a square wave. It jumps from positive 20 plus to the minus 10. So anything in between doesn't matter, because this thing is already shifted up. Okay, this value is already to 24.3 volts. And then whatever happens here is going to cut off. Diode will be off until this point, and then it will come back. Okay, depends on the input, because this is a wave. Okay, wave means it will be repeating like forever until it is turned off.